My name is Mohit Srivastav. I'm a GM in our front-end web and mobile developer space. I'm specifically responsible for AWS Amplify and AppSync, but also more broadly just looking at how we can take our relevant developer services and make them accessible to front-end developers as well. I'll be co-presenting with Nikhil Swaminathan. He's head of product for AWS Amplify. And he'll be joining around 20 minutes or so in here. Before I dive in, just show of hands, how many folks have used either Amplify or AppSync? Okay, the lights are so bright I cannot see, but I'm seeing roughly half the hands go up. And also before I get started, just hope you're having a wonderful re:Invent so far. I hope you're learning from each other, learning from the sessions, debating over your favorite launches. For me, it's been really humbling to talk to front-end developers at re:Invent this year, talk to customers at this earliest startups, talked at customers at enterprises, and it's been really fulfilling to hear what's going well and also fulfilling to hear some of the challenges and what could be better. So with that in mind, we'll kick off. We'll start, in fact, talking about developers. What you tell us is important for your users in a modern application, and how that translates into developer needs and requirements. Then we'll briefly cover some of the services that are especially relevant to front-end developers. But we're going to spend most of our time actually app building. And as we app build, we'll introduce the services even more, and we'll focus especially on features. It's called What's New. So we'll focus specifically on features that have launched over the last year, so since last re:Invent. And then finally, we'll kind of dive in to look at what we built under a microscope, and we'll look at the underlying architecture. So what do developers tell us on behalf of their users? Really, their users demand three things: fast applications, engaging applications, and trustworthy apps. Generally speaking, if you can hit these three things, you'll have at least a moderately successful, hopefully a really successful application. Just a couple pieces of nuance. When developers ask for fast, there's the obvious things like time to first byte and whatnot, but perceived performance is really important as well. So, for example, when a user interacts with the user interface, making sure the UI updates right away, even if the underlying call to a service may take a couple seconds. Conversely, if there's updates happening on the server, making sure they come back to the end user without any gestures, like they come back automatically via real-time updates, can also lead to perceived performance improvements. When it comes to engaging applications, of course, cross-platform, cross-device, all of that stuff remains super important. But the big trend over the last year, of course, is how can developers harness AI to make apps more engaging? And really, users don't care about AI. They care about the application just being better. But we're seeing AI being used in a few key ways. One is to drive actionable insights. So if any of you have gone to Amazon.com recently, you don't have to necessarily read through all the reviews anymore. Generative AI summarizes them for you. Right, so that provides actionable insights. The other use case we're really seeing is using UI to improve workflows. The canonical use case here, you start with a search box-like experience, but instead of that being one and done, it's sort of a bidirectional conversation with an AI agent, and users can accomplish tasks much faster than before. So we're going to dive into all of these actually in this talk. And then finally, of course, trust and security remains paramount. For our customers, that really unpacks into authentication, making sure authentication supports all the modern standards like passwordless, is frictionless, really easy for the user. And of course, once you're authenticated, it's critical that the data be secure and private. And if you look at these customer needs, they're not really exclusively front-end needs. They really require work across the front-end and back-end. And because of that, we've seen a lot of evolution. Hopefully some of these points resonate with you as well. We've seen how front-end development has become full stack, and it's being fueled by a lot of technology innovation. The first one is continued serverless innovation. So obviously, Lambda now is, I think, had its 10-year birthday party this re:Invent. But in the last year, there's been a lot of innovation in serverless when it comes to AI services like Bedrock and also real-time services. And as there's more serverless offerings for front-end developers, that's really fueled innovation on the JavaScript side. So we've seen front-end frameworks like React, Vue become full-stack frameworks. And as they become full-stack, we've seen TypeScript in particular really continue to grow because TypeScript gives you that type safety and predictability and correctness across the front-end and back-end. And as JavaScript popularity has grown, we've seen React Native, interestingly enough. For a while, people weren't sure if React Native is going to keep on growing or things like Flutter might take over. We've actually seen React Native market share grow the past year so that because developers want to use that same JavaScript code base for their native mobile apps as well. And of course, the most recent trend is developers are not writing all of this code from scratch anymore. They're using generative AI solutions like Amazon Q Developer to help. And then that, in turn, has been feeding innovation and cross-team collaboration and CI/CD, where deployment loops are being flattened from like 2 distinct deployment loops to a single deployment loop across front-end and back-end. And that, in turn, has fed innovation and observability, where it's obviously really critical. Now, if you have front-end and back-end code, you have async workflows, it's really critical that the observability solutions cut across the stack as well. So fun time to be a front-end / full-stack developer. I think that's the summary on this slide. Yes. And then kind of mapping to those developer needs or those technology trends, AWS has a number of services for full-stack development. The first one, Amazon Q Developer, is our generative AI assistant for developers. And just yesterday, there were a number of really exciting announcements with Amazon Q that we're going to dive into today. And we're going to use Amazon Q Developer in conjunction with AWS Amplify backend, which gives you a very declarative, code-first way of defining AWS backends based on use cases. So things like auth, data, storage, and AI. And it's all CDK. So at the end of the day, if what you need to do is not supported in Amplify backend, you can use CDK. And we'll see that today too. And as we go through this exercise and use Amplify backend, we're actually provisioning a number of AWS services. AWS AppSync for the backend API layer, Cognito for auth, Bedrock for generative AI, S3 for storage, DynamoDB for the database. For full stack deployment, we'll walk through Amplify Hosting, which is a fully managed hosting service. So it can take your front-end code and your back-end code in CDK and Amplify and deploy all of it together in that single development loop or deployment loop. For the test phase, we're not going to spend any time on this today. There's sessions on it elsewhere. Device Farm is a really great solution for then once your site has been deployed either to staging or to production, to be able to test it using real devices and browsers. And then finally, for observability, Amazon CloudWatch has really evolved into an end-to-end suite of solutions. So we can't cover all of that today. But I think for this audience and front-end developers in particular, CloudWatch RUM and CloudWatch Synthetic are really neat. CloudWatch RUM gives you both performance, error, and user monitoring, so like user journeys. And Synthetics gives you Canary. So these two things together are really powerful capabilities for end-to-end full-stack development. So with that, we'll introduce our app. We're going to build a car sales application today. We'll cover, it has all of the bread and butter functionality you might expect, so listings and search and all of that kind of stuff. But we're also going to try and differentiate and not make this just yet another car sales application. We're going to have some AI features. So we're going to have some of the stuff we just talked about, like conversational search and summarization. And not listed here, we're also going to have a real-time auction. So as a seller, you have the choice of just having a static listing or running your sale as an auction. So we're going to walk through all of that. And Nikhil and I will be kind of role-playing. So I've gotten the app started. I'm a classic front-end developer, so I've started off by implementing the UI using Tailwind. And I have not yet wired up the backend, so I just have mock data. And I've implemented some of the pages, so I have routing for some of the pages implemented. And with that, it's a good introduction to the first feature, which is Amazon Q now can generate developer documentation. So before I hand off to my poor colleague, Nikhil, with my poorly commented code, I want to help him out a little bit. I'm going to generate a README for him so he knows how to get started. And I'm going to do that using Amazon Q. So here's my app, and let's flip to VS Code, the IDE. All right, so what you see on the left is what I started with. If you're familiar with React and Next.js, it's pretty standard. I have a bunch of UI components, and then I'm pulling in those UI components together in a couple of pages. So what I can now do is go to the right-hand pane, launch Amazon Q, and I have a number of options here. I'm going to pick the /documentation capability, which launched, or /docs capability that launched yesterday. I have the choice to generate an entirely new README, which I'm going to do in this case since I don't have one, or I can update an existing README if I don't want to blow away what I already had. So here, I'm going to generate that completely new README. It just takes a few seconds. And I get a pretty comprehensive README here. So at the top, you'll see a nice short summary of what the application is about. And then you'll see below it a visualization of the file structure, nice and compact, using ASCII characters. And then this is really neat. It's actually taken an opinion and said, hey, Nikhil, these are the files you should give a special attention to. These are the key files in the application. And it turns out most of these files are the pages. So it makes sense that it flagged the pages as natural entry points. But it also flagged a bit of an unusual file here, a constants.ts. And I wasn't sure why. So I kind of opened that up. And indeed, it is an important file. So let's take a look. And you'll see that the constants.ts kind of defines the schema. Because right now, this is just using mock data. Constants.ts is defining the schema or the structure of this application. So indeed, it was an important file to highlight. Okay, so now if we go back to our readme.markdown, there's a few other interesting things that it flagged that are really valuable for Nikhil. It has some installation instructions on how to get past Go. It has some in narrative what it thinks the key features are. Some instructions around configuration, testing, and troubleshooting. And my favorite part, once this scrolls down a little bit more, is data flow. So it actually walks through how these components and the supporting code work together for the key data flows in the application. Okay, so now that I've done that, I feel less guilty handing off my poorly commented code to Nikhil. And I think he's in a good place to take over.
Hi, can I?
Oh, yeah.
Thank you, Mohit. As Mohit is my boss, he's given me the heavy lifting to do of actually going out and building the app backend using Amplify Gen 2, and I will also be using Q Developer through that process, as you'll see. So for those who are unfamiliar with Gen 2, we launched Gen 2 this May, as generally available. And what it gives is a code-first developer experience for building full-stack apps. You can now build your entire backend with TypeScript. So if you need auth, you got TypeScript. Data, TypeScript. AI, TypeScript. Storage, you get the picture. And because it's built on top of AWS CDK, it's fully extensible. That means you can add the 200+ AWS services for capabilities that are not natively available within Amplify backend. And Gen 2 is built for teams. So we have per developer sandboxes, so every developer in a team can iterate independently of each other. And when they're ready to share their code, they can simply commit their prod and staging branches, and updates to the front end and back end are deployed on every Git push. And because this experience is fully TypeScript, it actually lends itself really well to AI assistants such as Q. Because now you can generate your backend code with TypeScript and your front-end code with TypeScript. So in a way, you can build your full app. You can really leverage generative AI for your entire stack. What do we really mean by full-stack TypeScript? This video kind of shows you that on the left, you've got your front-end code, and on the back, you've got your back-end code. So anytime you make a change to your back-end, your front-end will go out of sync, and you'll get compile time errors. So this allows you to catch errors while you're coding instead of waiting for build times and waiting post-build to catch problems. And that's really why we leaned into TypeScript with Gen 2. So let's try and summarize our plan today. So Mohit gave me this application that's got UI working. It had a README file that's going to help me get started. And now what I'm going to do is add a data backend, wire up the UI to that data, add authentication, add an AI-powered conversational search experience. And then I'm going to hand it off back to Mohit to do the live auction, deploy it to production, and then set up observability. Getting started with Gen 2 is really easy. With a simple npm install command, run npm create amplify in the project that Mohit handed to me with the car trading app, I get a scaffolded set of files in my backend. So as you can see, there's an amplify folder here with auth, data, resource, TS files. With Gen 2, we've taken a file-based convention, so all your backend definitions are defined in these resource TS files. We think about what we're doing more as infrastructure from code than infrastructure as code. Because for your backend definitions, what we're setting up, the default scaffold sets up is you log in with email. You can extend that to add face social sign-in, multi-factor auth. For data, you get a schema. And the schema here defines a to-do schema, but we're going to modify that right after this. And when you deploy this, it deploys real AWS services. So you get a Cognito user pool, an identity pool for auth. And for data, you have an app sync for your API layer and DynamoDB tables and optional Lambda functions too. All right, so let's actually get started now. Let's actually start building something. So we're going to add a data backend to our app. So this default to-do schema that's in this file is no good for me. And I want to hand author a car listing schema. So I could have that option. So what I can do here is I can type out listing. And because it's all TypeScript, I get type completion. So I can create a model. And with this model, because I have Q running, it'll auto-suggest a bunch of fields. But I don't think these fields are the right fields from the README that Mohit showed me. So I'm now going to have to go through my entire code base, find what all the mock data is, and actually update my schema with all the different types. I'm feeling kind of lazy, so I open up my friendly AI assistant, Amazon Q. I open up the assistant, Amazon Q, and I basically I'm going to. Just give me 1 second. Sorry, there's a little problem with the video. So while that happens, while it plays forward, with Q, what I'm going to be able to do is that I'm going to be able to write out a prompt, and actually, what it'll do is it'll actually scaffold out my entire backend. So while this replays, what I'm going to talk about is really like the schema. The schema here is fully typed, and what it'll do is it'll deploy. When it does deploy, we're going to deploy real AWS services. All right, so let's take a look at this prompt. So what I'm inserting into this prompt is a message. Is a message that basically says that, hey, inspect my /app and my /components folder to see if there's mock data available that can be used to inform my data model. Amazon Q recently launched this @workspace directive that gives the chat access to the entire code base. So it can scan files to figure out where the right information is. And we're also leveraging that to actually enhance the accuracy of Q. We've published a docs folder that has markdown files and custom prompts that Q can use to enhance accuracy even further. And this is all available in our public documentation. So I'm going to go ahead now and submit this. And when I do submit this, Q is now going to, let's see what Q comes up with. So it generated a car listing model and a seller model. And as you can see, the seller model has a one-to-many relationship with car listings, which makes sense. And then there's authorization rules that they've defined on who has access to what. And as you can see, it also gives you a summary here. It used the rules that I've defined to kind of enhance the syntax. And then for the schema, the car listing mock data, it found mock data in the search results and like the page.tsx, and it used that to inform my listing schema. So for V1 of this, I'm going to not involve the seller. I'm just going to stick to the car listing. So I'm going to ask you to remove the seller model and just stick to the car listing model instead. Great, so it generated a result. And what I'm going to do is I'm just going to copy and paste this entire thing into my resource.ts file and see what happens. One of the benefits of TypeScript is that when I do paste this in, I'm going to see problems right away. So this experience where you can chat and copy-paste code really works well with TypeScript because you can catch errors in compile time versus build time. So as I can see here, it appears on line 19. We have a photos field, and a.array is not really a thing. So instead of going to the documentation to figuring out what that is, I can just use .completion, and I put a string, and there's an array field on a string. OK, so there you go. So I can just very easily, quickly update the one thing that Q got wrong. And now the next part I'm going to kind of look at is the authorization rules. So authorization defines who has access to what, and Amplify's schema allows you to do that in a very simple way. So if I look at the rules here, it's saying that owners, so people who sign in and own the data, can perform CRUD operations. Sounds right to me. And guests, that means people who have no access can read, create, and delete. I don't think I want my guests to be creating and deleting listings, so I'm just going to delete that. And there we go. Our data schema is now completely ready. And now we're going to learn how to deploy this. So as I talked about earlier, Gen 2 has this concept of cloud sandboxes. The way I think about it, it's almost like npm run dev, but for the backend. So every developer on a team can iterate independently of the other. And I never have to worry about clobbering Mohit's changes, and we can work in parallel. And the iteration experience is very much like how you iterate on your front end. So you start with the sandbox, you make edits to your front end, your data resource TS, update your front end code. On save, it adds a database table, and you see your UI. All the changes happen on every save, just like how it happens on your front end. And now what we're going to do is we're going to actually see what the deploy experience looks like. So when I run npx ampex sandbox, this is going to start off a deployment. And the deployment's going to happen using CloudFormation. Now, the first deployment is going to take a couple of minutes because we're deploying, in this case, we're deploying auth and data. And so this deployment takes about 2 minutes. But then what we've done is we've optimized iteration experiences, especially for your data schema, to happen in seconds when it would otherwise take minutes to deploy. So once this deployment completes, as you can see, there's a whole bunch of resource identifiers here that actually define what we have deployed. And now what I'm going to do to highlight the iteration experience is that I'm actually just going to add a new field to this. And with the new field, what we'll observe is that the deployment happens much faster. So if I go into my schema, let's add a new condition field that kind of highlights the condition of the car. And on hitting save, the sandbox is automatically watching the file for changes. So the deployment will happen automatically. And usually what happens is while the deployment happens, you're going to go to your front-end code and update your front-end code. So you won't even notice that it's taken like 15 seconds to deploy. And by the time you make your front-end code edits, that change will already be deployed to the cloud. Now that we've done this, what we need to do is actually, we've deployed our backend, now, but we've not really made any UI changes yet. So we need to connect our UI to the database we just deployed. So I open the search results.tsx file, and what I notice is like it's got all 3 mock listings. And these I've already generated some seed data in my database to create 16 records. So what I'm going to try and do now is actually use Q to update this file and generate the code that's needed to connect to this data. So again, Q has context of the file in window always. So it's looking at the file, and then it's going to suggest updates. So there's a lot of updates. So this file has a lot of updates. So one good thing it does, it also talks about the key changes made, right? So if we actually look at the key changes made here, first, it added Amplify configuration and client setup. That basically initializes the client so it can talk to the database. It replaced the mock listings with real data using our client.list function. It added loading state management, because now that we're actually interacting with real data, there's going to be some load time, so adding state management for loading. It updated all the state types to actually use real types instead of mock types, and a loading indicator to the UI. Now, my personal preference here is to kind of hand author the pieces, like copy paste component parts of this versus wholesale, since it's such a big change. So first I'm going to get the imports in, make sure that's all right. So this first part of the code, make sure that I've got the imports look okay, and I'm going to initialize the Amplify client to be able to talk to the database. No errors, I'm good to go. Next, I'm going to update the use state, the different hooks that are in the application, and replace this content, this mock listing array. So as you can see, the listings, listings use state hook is now actually using my real schema, which is the car listing schema that we define in the data resource.ts. And if you look at the type, like this has all the type information available. So you'll see, make, model, year, price, everything that we define in data resource.ts. And it also added a loading, because now we have to manage loading state. It also added a use state hook for loading. The next part of this is the use effect. Use effect is basically called every time a page loads. So I'm going to copy this use effect into the application. Now what I can see is it's starting with the set loading. It's getting the car listings from the database, and then it's applying a sort to the listings. I don't really want this sort for my first iteration, so I'm just going to remove it to keep things simple. I see I have some variables to fix, so I'm going to do that. And then I'm going to use Q inline chat to just say generate a console.log if there's an error for the car listings, so I can catch the error in my client if there is indeed one. Okay, so this looks good. Now the front-end code doesn't look very good, so I want something that's easy to copy and paste into my application. So I'm going to ask Q again, can you just generate this UI code, make sure there's a loading screen, and make it easily copyable so I can just replace my return block with the right code. All right, so Q's generated that. I'm just going to copy that, and it's also going to give me an overview of what it did. So it's got loading state, there's an empty state, and there's a result state. So I'm just going to paste that in again and see if there are any errors that TypeScript complains about. Looks like there are 2 errors in this file right now. So let's go ahead and fix it. The first one is a simple syntax issue. And the second one is a mismatch of type, because my results view component is still referencing my mock data. So let's actually go into that component and fix it. So there you can see on line 7, it's using my mock type, right? My mock interface. So let's actually use the real schema from our data resource.ts file. And then update the interface to actually use that schema. And that should fix it. So if we go back to our search results file, you can see TypeScript's no longer complaining about issues. And now in our UI, we can now see 16, there's a loading screen, and we can see 16 vehicles, just like what was there in my database. The data client has many other features. We have an observe query feature that allows you to see real-time subscriptions. So if I wanted to have, as listings get added, I wanted them to show up in my UI automatically, I could add real-time capabilities. I can do selection sets, filters, and pagination to optimize network requests. Great, so now that we've got a data backend up, we wired up the UI to the data, let's actually go ahead and see how we can add auth. The default scaffold of the npm create amplify already created a login with email, but we can extend this, again, using our TypeScript experience to add more external providers, Amazon, Google, Facebook, Apple. We can add features like multi-factor auth or the newly released passwordless support from Cognito, and then deploy it just like we did with data. Once that's deployed, we can start writing our login UI. So to get started, I first create a new login route using Next.js's app router. That's got a login page. And this time, instead of actually using the queue chat, I'm actually going to try and hand author this using the Authenticator, which is a UI component that we offer. And because it's only a few lines of code, I don't think I need queues chat. But here, Q is giving me inline suggestions of what to do. So I'm tabbing, and it's telling me what to put in there. So here I'm basically reinitializing my Amplify client where I'm saying, OK, let's get the config information in from our outputs. And I will call .configure again. And Q, again, is suggesting recommendations for me based on what I need to do. I see that I have a little syntax error with my config. I'm going to fix that. And now I'm just going to write my function for my auth UI. As you can see, Q's automatically suggested the code I need. So I just hit tab. And I think this is enough to get me started. This is an authenticator component. So let's go back to our browser. And now we have sign-in, sign-up flows done in under a minute. I'm going to make a few tweaks to this. I'm going to get the user context in the authenticator so that when I sign in, I'm able to see the user information for testing. And I'm actually going to give this a spin. I've already created a user in Cognito. So if I go to Cognito, you'll see there's a user there. So what I'm going to do is sign in and show that that this works. And as you can see, I'm signed in with the user. And now on sign out, I see my authenticator again. But what I want to do now is actually edit the authenticator to match the rest of my application's look and feel, which is all black. So I'm going to import our UI theme component that allows us to actually edit the theme. And again, I'm going to rely on Q to come up with recommendations on what I should do as I type. So I first create the tokens, then it's like, OK, now here's the theme object, and maybe these are the tokens you want to edit. I only want to really edit the primary color, and I know that there's like 2 or 3 different tokens that are black that I'm going to change for now, just to get it to match. And then I'm going to wrap my authenticator with the theme provider component. And there you have it. It now looks and feels like the rest of the application. And I can add things like social logins very easily. There are TypeScript props available for that. So in this case, if I want to add social providers, I just add the social providers prop and add things like Amazon, Apple, and Google, or Facebook. There you go. So just in a few lines of code, with a few lines of code, we've got a auth backend deployed. We've implemented our UI components, and we've got this full stack functionality working. So now let's go to the next part of adding an AI-powered conversational search experience to our application using the newly released Amplify AI Kit. The Amplify AI Kit takes the same TypeScript-based experience we saw for data and auth and applies it to AI to help you build AI-powered experiences really fast. What you can do is actually easily provide LLMs secure access to your data. And all of that happens server-side, so you'll never enter a situation where you have to worry about leaking sensitive user information to your LLM. And this simplifies two use cases, the first one being building chat and conversational search UIs, and the second one's around one-shot generation, so use cases like summarization and image generation. We also offer built-in tool support, so what that allows you to LLMs to invoke external APIs to pull data that you can give the LLM context about. So let's see this in action. So the first thing I'm going to do is define actually define a new route here. And with the data resource.ts file is where my data definition is, and I'm going to add what we call a conversation route. A conversation route is a new route in AppSync that allows AppSync to then communicate with the LLMs, in this case Bedrock, and Bedrock has a Claude 3.5 Sonnet model that we're using. Now we can pick any model available in Bedrock, so and you get that in the type completion. So if I want to use Haiku, I can use Haiku, or post reinvent, we're going to add the new Nova models available. And this system prompt will allow you to edit the information the LLM needs. So I can edit this to be more context specific. And then the tools, the data tool in specific, allows me to reference my car listing model. So what I can do is I can provide information about my listings to the LLM. So the LLM can use that when the user searches for information. So now that the backend is set up, let's actually set up our front-end chat route. So with the AI kit, we offer AI hooks. So the AI conversation hook in this case gives you, the use AI conversation hook will give you things like messages, message history, and all of this is, persistence is built in, so you're able to like sort and filter through things if you want to build your own UI. But in this case, we also have an AI conversation UI component. So what that gives you is the ability to not just, to actually get a UI component working out of the box. So you've got, you pass the messages, it's got a message renderer. So what you can do is say, hey, I want a React Markdown renderer, so the chats render well. DS loading state allows you to have like a loading state for when you're interfacing with the chat. And the handle send message is a function that's also pre-built. So let's see this in action. So what I'm going to test is, can you find me cars that are available in the West Coast? And now this is going to invoke AppSync that invokes Bedrock. And we're getting a response from Claude. And as you can see in the message, they say they have access to the car listing tool. And what you'll see coming up soon is that it provides information about specific cars available in the West Coast. So what you're seeing, the cars being returned right now, are actual results from the database. So you can see it's like there's a Tesla Model Y, there's a Porsche, all of that's the data available in the database. And I can enhance this even further. So we've got conversational UI built in, so we can also give the LLM components from our application. So in this case, the car card component can be passed via a response component prop. So you can build rich interactions where the LLM returns a UI component instead of just returning raw text. The generation routes are slightly different. They're more single shot. That means if you want to generate summaries or if you want to generate an image, you're also able to do that with our use AI generation hook. So in this case, I've got a generate car listing. I've got a generate car listing function. So, and I pass a prompt of defining a car listing for this component based on the selected fields. So what I want to do is for users creating new listings, I'll give them a UI where there's a generate from AI button where they can very easily generate descriptions for their application using LLMs. So with a single click of a button, you see here that a description is generated using the generation routes. There are additional features that we're not able to demo here. So you can bring your own data, connect to knowledge bases, and you have features like multimodal search. So now that we've added these three features, the last feature to add we have is the live auction feature. But before we do that, we just want to summarize all the different things we just saw. We saw the /doc experience to generate a README. We didn't see /review, but /review for Amazon Q helps you detect security vulnerabilities and quality issues while you're developing. /dev, Mohit will be demoing /dev to talk about feature development. We saw at Workspace giving chat access to the entire code base. And then inline chat is a new feature that is like a popover chat while you're coding. And for Amplify backend, there's a whole bunch of new features across auth, data storage, functions, and of course AI. On auth, we just recently launched passwordless support. With data, you can now bring in existing Postgres and MySQL databases. On storage, we have a storage browser UI component that allows you to build admin interfaces with Dropbox-like interfaces. And with functions, we have a number of features around cron jobs, long-running tasks, and you can also stream logs directly to your sandbox. The main reason we see customers picking Amplify backend is because they're getting their infrastructure from code, and they can ship faster and deliver value faster to customers. And with that, I'm going to hand it back to Mohit to add real-time capabilities using AppSync events.
My mic on? Yep. All right, so for those of you who are familiar with AppSync until a couple weeks ago was exclusively a GraphQL service. And we launched a new capability for building real-time applications called AppSync events that now lets you take advantage of that same subscription feature we had in AppSync, but just using pure WebSockets instead. So before we dive into that, let's quickly add more user interface. So let's add UI for doing auctions. So I'm going to run this /dev command. And /dev is different than what Nikhil showed in that it generates multiple files. So it will introspect your code base and generate multiple files. So I'm asking /dev, hey, update my UI to support auction listings. Give me a test page with mock data so I can try it out. And then what it does is over multiple passes, it comes up with a plan and starts implementing that plan. So what you can see here, it reviewed 6 files. It decided actually for this use case, it's not going to update anything. Instead, it's going to create 3 net new files, a page, a page file, a couple of pages, and a UI component in this case. And I can choose to accept, or I can say, you know what, this is not quite right yet. I'm going to give you some more feedback. Try again. In this case, I will accept. And indeed, what came back is pretty decent. It looks like that sales page that Nikhil had, but now with an auction listing widget on the right-hand side. Of course, this is all static. What's missing is we want this to be updating in real time. So for example, when this $125,000 starting bid for this Tesla S, must be a plaid model at that price, I want obviously the bids to update in real time. So how can we do that using AppSync events? And what AppSync events does, again, is it provides just fully serverless WebSockets. It's features that AppSync has had in the past, but buried behind GraphQL, now just first-class WebSockets. It allows you to create real-time experiences in minutes, and because it's serverless, you're not having to deal with the operational overhead. And as compared to alternatives like polling, it can be a lot faster and lower your total overall costs. And what we're going to do visually first, it's pretty simple actually. The audience, so that's people making bids on this Model 3 or this Model S plaid. Basically, all they're doing under the hood is publishing to a namespace and a topic. So in this case, auctions with the auction ID. Architecturally, you have two choices. You could have your clients do this directly, or what probably makes more sense in this application is I would instead have an API that goes to a server, and the server would actually be submitting the publish event. On the subscription side, there's a kind of complementary API where I can just subscribe to that namespace and that topic. From a coding perspective, it is pure HTTP for publish and pure WebSockets for subscribe. And you can certainly do it directly from your browser. We have a bunch of documentation for doing that. Alternatively, you can use the client we've created. It's part of the Amplify client library. And you can see it's really simple. You can publish basically in one line of code, arbitrary JSON, and then you can subscribe in a few lines of code as well. And that's really all there is to doing that. And now that we've finally built the app, let's deploy it and now observe it. A quick introduction to Amplify hosting. How many folks have used the hosting part of Amplify? Gonna have to put my visors up, okay? Smaller number. So the basic idea with Amplify hosting is you can provide your source code for both static applications and SSR applications, and that's it. And in exchange for providing your source code, your app will be globally hosted. There's easy custom domains. The backend and frontend get co-deployed in that single continuous deployment loop we were talking about. You get feature branches automatically, so basically every branch that you have in GitHub can become its own subdomain. And you can optionally, with a checkbox, turn on basic auth, in addition to any authentication you might have in the application. And I think the really unique part of Amplify hosting is it doesn't stop with SSR. It actually extends to the backend. So in this case, if I have like a dev feature branch, for example, when I check it into source control, what's getting deployed is not just the static or SSR application. It's also the backend as well. And just to see it in action really quick, it's pretty simple. I'm at the console. I can pick my source control repo of choice. Just a few weeks ago, we also launched the ability to point to an S3 bucket, but either way is fine. I'm going to use GitHub in this case. I can list out all of my GitHub repositories. I can pick the branch, and since I want to do a staging pre-prod deployment, I'm going to pick my add backend feature branch. And you can see here, it figured out, okay, this is not just an SSR application. It's an SSR application with a backend as well. Oops, and that's it. It's deployed. A few months ago, kind of extending this philosophy of basically making smart defaults and making things turnkey, we also launched optimized caching policies, again with smart defaults. And the idea is we actually introspect your application, and based on the kind of content that's in your application, we'll make some decisions. So regardless, the caching duration is up to a year. If you deploy a fresh version of your site, will invalidate the cache. So that's sort of a given. But let's say you have static content. You don't necessarily want that static. You want the cache view for the static content, generally speaking, to ignore cookies. And you want it to ignore query strings because it's going to be the same static content by definition, regardless. That said, SSR content, API routes, reverse proxies are the exact opposite. You do want to honor the query string. You do want to honor the cookies. You do want to honor certain headers and include those in the cache key because those might drive specialized rendering of the page. So that's what we do. And image optimization sort of falls in the middle. With image optimization, the query string will define like what size image gets served. So it's important to include that in the cache key, which we do. But your cookies won't really have any impact. So we do all of this stuff automatically. And then coming soon, one more thing we'll be adding and trying to make it pretty easy from a turnkey perspective with the ability to do more is firewall support. So I know it's been something customers have been asking for a while, launching quite soon. Okay, and finally, we're going to, now that our app is developed and deployed, we're going to observe the application. And we're going to use CloudWatch. Okay, and we're going to configure CloudWatch the same way we've been configuring all of these other services, even though CloudWatch is not something built into Amplify backend just yet. So I open up that backend.typescript file again, and because Amplify is ultimately CDK, I can define a CloudWatch RUM app monitor using CDK. And what's really neat is you can reference the built-in functionality. So to configure CloudWatch RUM in this case, I need some of the Cognito identity pool information, and I can very easily pull that by referencing the Amplify's auth resource right above. You can see in the highlight. And then likewise, on the client side, I want to make sure this instance of my client is using the right instance of CloudWatch RUM, and I want it to work no matter how many environments I have. So instead of hard coding the identity pool, what I can do is I can reference that backend information right here. So you can see here outputs, which is the output of the backend configuration, .auth, .identity pool, allows me to reference the backend from the client without any hard coding. So no matter how many environments I have, this will just work. And in return, I get a really neat set of capabilities. You can see this CloudWatch RUM dashboard provides performance, it provides errors, it provides user journeys. I get a number of metrics just for free, like page loads and loads time didn't require really any custom instrumentation. And then errors did. I instrumented my app where I had some custom errors, and that's what you see on the right-hand side. Kind of diving in a little bit deeper, this is a really neat view where I can see my load time based on time of day. There's different sort of thresholds defined for like a delightful experience versus a super annoying experience. Luckily, Nikhil's in my app is looking pretty delightful. And then going beyond just those kind of high-level metrics, you can go into vitals sort of metrics. I can see how long at the P75 level in this case, first paint is taking. I can see how long it takes before users can provide their first input. And I can see how much my layout is sort of shifting around as things are loading, which can be very frustrating for customers. Again, I'm happy to see app is solidly in the green. And then finally, beyond performance metrics, you can also instrument user journeys. And actually here I did no instrumentation. So this is what you get just built in. So I can see that there were no drop-offs on the landing page. First interaction, there were 4 drop-offs. On second interaction, there were 2. And this is just based on what you get automatically. You can customize this as well to include things beyond just page transitions. And because CloudWatch RUM is integrated with X-Ray, I kind of get that full stack trace we've been talking about as well. So you can see here, if you look at the user on the left, you can see the user's interactions on the local machine visualized as localhost. In this case, or on the client, it would have been the Amplify hosting if it was in production. And you can see the interactions on the back end, like AppSync and DynamoDB, all in a single view. And then if I dive into this, it's really neat. I can go into a service like AppSync, and I can actually, because AppSync has X-Ray integration, not just CloudWatch RUM, I can actually go into what's happening in AppSync as well when I call this get data call. So I can see, okay, this get car listing call is unpacking into all of these AppSync operations, and if I had a longer screen, you could then see what was happening in DynamoDB as well. And then finally, once my app is in production, I can use CloudWatch Synthetics to set up canaries. I haven't done that for this particular talk because a bunch of these are pretty self-explanatory. But long story short, there's built-in ones, which are just kind of the ones you would expect, like API checking and heartbeat monitoring. There's point and click and recording ways to kind of create your own. Or you can just hand author them using the inline editor or importing from S3. And both CloudWatch RUM and CloudWatch Synthetics have had some pretty meaningful launches the past few months. CloudWatch RUM, for auditing purposes, now audits all of the put events. And then CloudWatch Synthetics, if you're going to be hand authoring tests, now supports Playwright, which is a pretty popular tool in the JavaScript and Node.js community. Okay, with that, our app is developed, deployed, and monitored. And let's just take a look under the hood of what we were able to build in the duration of this talk today. So we ended up with an AWS backend, which has a number of services: Amplify hosting for the front end, Cognito for identity, AppSync as that API layer, and behind these services, a bunch of supporting services: Lambda, DynamoDB. I ran out of space, but also Bedrock, Bedrock obviously for the generative AI functionality. And the user flow is relatively straightforward. User hits their browser window, and that triggers Amplify hosting, which can serve static, SSR content, or a mix of both. Once that's done, if the user's not yet authenticated, it will prompt the user to log into the application using that authenticator component that Nikhil showed. And then finally, when the user starts browsing cars, the API calls go through AWS AppSync, which provides that access control layer as well. And then when we did the auction, we also used AppSync. We didn't use GraphQL in that case. We used AppSync's sort of event API to be able to receive, to publish and subscribe to auction events. And that's what we built in just a matter of 55 minutes or so. So with that, I want to extend a thank you for being a wonderful audience. Nikhil and I can't say Twitter anymore, our X account information is right here. I'm also on Blue Sky now, but I forgot to put that here. And I think we can take questions for a few minutes. And thank you again for being a wonderful audience. Enjoy the rest of your reInvent.